I would like to welcome all of you to today's lecture. The lecture is basically on hypothesis. Hypothesis. It is going to be fast-paced, and so the only way you can um, work around me is asking questions. That is the only way. The moment you stay back, you will not be able to enjoy it much. Secondly, please have a notebook with you, even when you are sitting by to do the work. Thirdly, we shall be using the R and the R Studio a lot at some point. So get your computer and the R opened, the R Studio in particular opened. Also, we will do some handiwork. So please follow along when we are doing those handiwork. So let's start with a hypothesis. What is a hypothesis? What do you give me a synonym for hypothesis? Anybody? Give me a synonym for a hypothesis. A claim, an assumption about a population parameter, a speculation, a conjecture, a projection, a forecast. All of these carry the idea of a hypothesis. So a hypothesis is a statement about a population parameter, which is usually unknown. Now, what I mean by a population parameter is that something that represents the population. It can be the mean, it can be the median, it can be the standard deviation, it can be the mode, it can be the variance, it can be the ketosis or any other statistic. Usually, a hypothesis is made up of two things. There are two different kinds of hypotheses. We shall come to that. But I want you to know that a hypothesis is a statement. For example, income has a positive effect on consumption. That is a hypothesis. But the same sentence or statement can be converted into a question. Who can convert this statement into a question? Who can convert the statement that says income has a positive effect on consumption? Remember, I've told you that if you don't participate along with me, you will later say at some point that I'm moving too fast. So the only way I do not move too fast is when you are answering my questions and participating. That is the only way. Okay. So income has a positive effect on consumption. Convert that into a sentence, into a question. That is going to be, does income have a positive effect on consumption? This second one is a question. Are socially responsible firms more profitable? Convert that into a statement. And you have socially responsible firms are more profitable. So a research question can be converted into a research statement. And a research statement can be converted into a research question. So let's go back to our two types of hypothesis. The first one is the null hypothesis. It is represented by H naught, the null hypothesis. What is that? The null hypothesis is usually an authoritative statement from someone who has an authority to what he's saying. The alternative hypothesis is usually the mirror image, opposite of the null hypothesis. Let's say, for example, I make a statement. No, let's say, for example, the Electoral Commission makes a statement that NDC will win the next election. And Kwaku Bakum makes a statement that NPP will win the next election. Which of these two statements will shake the country? Which one is more likely to cause some kind of deep discussion in the country?
The one made by the EC, the Electoral Commission.
Exactly, because that the EC has an authority. Therefore, that statement is said to be the null hypothesis. The alternative is the one that Kwaku Bakum made. It does not behold on the IC to make that, to justify, to prove. The one who says the EC is lying is the one who should prove it. So understand the null and alternative hypothesis. Once again, we shall come back to the null and the alternative hypothesis. But for now, let's look at the steps in hypothesis testing. I want you to be writing some of these steps down because it's the only way you will appreciate them. There are 4 steps in hypothesis testing. Step 1, formulate the null and the alternative hypothesis. That is step 1. Formulate. In other words, write it down in English and write it down in statistics. Step 2, compute the...
Sorry, Doc. Can you please take the step 1 again?
Step 1 is on your screen. Formulate the null and alternative hypothesis. It's right on your screen. Step 2 is to compute the test statistic and compare it with a critical value. Compute the test statistic and compare it with a critical value. Step 3 is to find the p-value and alpha. Find the p-value and alpha. And the final step is to decide and conclude statistically and practically. Decide and conclude statistically and practically. Let's go back to the step 1 and understand some few things. There are some few things that you want to understand. The null hypothesis. You see, one thing about a null hypothesis is that there is something about a null hypothesis which carries an idea of an equality. So you want to take note of, you see, there are some statements we make usually by ourselves, and these statements by themselves can be written in statistics. For example, if somebody should say the word below, what statistical symbol will represent below? Below. Is it going to be greater than, less than, greater or equal to, less or equal to, equal to, not equal to? Which of these symbols is going to represent below?
Less than.
Less than.
Less than. What is the opposite of less than?
Greater.
Greater than.
It's not greater than. The opposite of less than is greater or equal to. And the opposite of greater than is less or equal to. And the opposite of not equal to is equal to. Now, why is the opposite of less than not greater than? Because once you say somebody is less than 30, and you tell me that the opposite is greater than 30, so why will you place 30? You would have thrown 30 away. And so the opposite of less than is anything below 30, which means its opposite is going to be 30 itself and anything above it. That is why less than, its opposite is greater or equal to. There are some other English words that can represent less than, greater than, and all of that. For example, which symbol will represent above? What symbol will represent above? What symbol?
Greater than.
Greater than. What symbol will represent at least? At least is greater or equal to. What symbol will represent at most? Write them down. These are the exam questions have already been set on these. That's why I say write them down. What symbol will represent at most? At most.
Greater than or equal to.
Greater than or equal to. And what symbol is going to represent not equal to? What symbol is going to represent not equal to? Or let me put it this way. If you say that different from, what symbol is that?
Sorry,
If,
sorry, please come again.
huh?
Please come again.
Which
Not
of these symbols is different from?
not equal to.
Which of those
Not equal
symbols
to.
is the same as?
Not
The same
equal.
as. So you should know English words that actually connect with these words. There's 7 marks on this in the exam, so note it. All right, so the key point is that the null hypothesis, and this is the key of all that we've said so far, the null hypothesis, write it down, always carries some level of equality in it. This is already in your note. Everything I'm saying is already in your note. The null hypothesis always has some level of equality in it. Write that down. You won't forget it. The null hypothesis always has some equality in it. So that's about step 1 in hypothesis testing. The step 1, when you are formulating it, you have to have the null hypothesis. And you will always write it in such a way that you have the null written with equality. So for example, suppose I say that the average age of students in this EMBA class, the average age of students in this EMBA class is 36. Suppose I say that. And I want to write that this is a null hypothesis. Sorry, this is a hypothesis. But in order to determine whether it is a null or alternative, you need to follow the following steps. How do we write this in the null and alternative hypothesis for this statement? First of all, we are talking about average. And the symbol for that average is mu. So you write mu, which is a population mean. Then you will now say, you leave a gap and write 36 years. You do the same thing again, new, and write 36 years. Then you will look for what symbol is inside, whether silently or not silently. What symbol is in this sentence that is one of the symbols I just showed you? The average age of the EMBA students is 36 years. What symbol is actually being spoken of here? Out of the 6 symbols, which one? The average age of students in the EMBA class is 36 years. Is it less than symbol? Is it greater than? Is it less or equal to? Is it greater or equal to? Okay. Is it not equal to? Is it equal to? Which one is being spoken of here? Well, the word is, average age of EMBA student is 36 years. That is implies equal to. Therefore, the symbol in question is equal to. Once you have identified that equal to for the first part or the second part, it can be any one of them. Step back. Think. Ask yourself this question. What is the opposite of the symbol I just wrote down? So let me ask you, ladies and gentlemen, what is the opposite of the equal to symbol? What is the opposite?
Not equal to.
Equal to.
In that case, you will write the not equal to symbol. Then you bring a colon in front of each one of them and step back again. And then remember the statement you just wrote down, because I'm going to ask you a question. With these 2 information you are seeing here, which one is the null and which one is alternative? Is it the top one or the down one? Which one is the null and which one is alternative?
Top one is now.
Why?
It has some equality in them.
Perfect. Therefore, you will write H naught for the top one, and you will write HA for the second one. So that is how you are able to formulate the null and alternative hypothesis. For example, there could be several ones. And again, when you check the videos that I have for you, you will see a number of those examples on my channel. Also, when you go through this document here, which you all have, you will see that I've given you so many examples. Learn them. The second step in hypothesis is compute the test statistic and the critical value. There are several test statistics you can compute depending on what you are dealing with. Write some of them down. The first one is the Z-test. The second is the T-test. The third is the U-test. The fourth is the chi-square. The fifth is the F-test. And so on and so forth. You have the W-test and several. These are all test statistics. What is that? What is that? Anytime you are doing a research, you will usually collect information. Whether it's qualitative or quantitative, you collect data. When you collect the data, you will estimate something, a statistic, like the mean, the median, the mode, standard deviation, variance, and so forth. After you've estimated the statistic, you will now calculate the statistic properly. That statistic is like information gathering value. Write it down, you might forget. The test statistic is the information gathering value. And you always need to compare it with another value. That value is actually not information gathering value. It is a benchmark value. And this benchmark value is known as the critical value. The critical value is not actually calculated from your information you have collected. It is actually like the measuring rod, the benchmark against which everybody compares. For example, let me ask you today, if you want to compare your country, okay, which country is the benchmark that every country would like to compare themselves with, generally speaking? Which country?
America.
America is a benchmark country. Now, today, if you want to compare your university as one of the greatest universities in the world, which two major universities are you likely to compare your university with? Or which one will always come up? Which university?
Harvard, Yale.
Harvard University.
Harvard. So again, there is a benchmark that you will always have to compare yourself with. The same way when you are doing a research and you're calculating a statistic, there is always a critical value, a benchmark value that you will compare your information gathering value with. And this is known as the critical value. The information gathering value you collected is a test statistic. Sometimes the test statistic is also called the calculated value. And the critical value is called the tabulated value. The critical value is called tabulated because you normally pick it from the table. You pick it from the table. And that is exactly why it's called the tabulated value. We'll come back to this in the practical example. Now, next thing, step 3 in hypothesis testing. And by the way, you got to know all of these four steps. The step 3 is to find the p-value and compare it with alpha. Please note, alpha will always be given to you. Please write this down. Whenever alpha is not given to you, use 5% as the default alpha. I'll talk about alpha very soon. What is the difference between p-value and alpha? We are doing research, aren't we? And anytime you're doing research, you're likely to make some mistakes. Some way, somehow, you'll make some mistake along the way. Yes, it's okay. We are allowed to make mistakes. But there is a limit to the mistake you are expected to make. The fact that we are allowed to make a mistake does not mean you should just be making mistake by heart. The alpha is the mistake or the error you are allowed to make in a research. Write it down. You forget. Write it down. Yeah. The alpha is a mistake or the error you are allowed to make. Sometimes we call it the level of significance. The level of significance. And again, you see it in the note. Now, there are three major alphas that are used in the literature. 1%, that's the first alpha. 5%, and finally 10%. These are the three major alphas. And I've already told you that which one is the default.
5%.
5%.
When the default is given, is not when no alpha is given to you, the default is 5%. So this is the case. Every research you are doing, you will be given, or you are given a certain level of alpha to deal with. Whether it's 1% or 10% or 5%, you'll be given. That is the error you are allowed to make. You should not exceed that error. Once you exceed the error, you do not have enough gravitas to reject the null hypothesis. Once you exceed the error, you have no macho to speak against the null hypothesis. But there's another error. That error is the p-value. The p-value is not the expected error, but rather the actual error you made. The error you actually make, not the error you are expected or allowed to make. Write it down. So the p-value is the actual error. Question. Which of these two errors do you think must be smaller? Is it the p-value or the alpha?
The alpha.
Alpha.
The alpha, are you sure? No.
The
It's
p-value.
not alpha. If you have been following me
But
carefully,
you said the p-value is the
The actual.
actual error.
yes,
So
Yeah.
if it's the
if you
actual,
go into a research and you actually made an error, and you are expected to make a certain error, which one would you wish it is smaller?
The actual.
You get a
The
point?
p-value.
Yeah, the actual, because that is the one you made. You want to make an actual error which is smaller than what you are expected to do. So if you are expecting me to make a mistake of 10% and I make 0% mistake, it means that you lose. I win because I have made less mistake than you expected. You are expecting me to make a mistake. Okay, in that case, I will make less mistake. Because you see, when your p-value is smaller, it means that you did not make much mistakes. And therefore, your confidence level will be high. So write this down. The lower the p-value, the higher the confidence interval. The lower the p-value, the higher the confidence interval. The lower the p-value, the higher the confidence level. So anytime you do the research, you want the p-value to be smaller. So write it down. You reject the null hypothesis if the p-value is less than the alpha. That's an important statement. I won't lie to you. You reject the p-value, you reject the null hypothesis if the p-value is less than alpha. Now, what about the test statistic? The same thing. You reject the null hypothesis. Note that. You reject the null hypothesis if the test statistic is greater than the critical value. If the test statistic is greater than the critical, please, your colleagues are writing, so please write it down. Because when you write it down, it's going to help you big time when you ever need it. Even if you don't understand, write it down. Once you have finished step 3 and you now have your p-value and the alpha, you can now decide. The decision rule is what I gave you. When the null hypothesis, when the test statistic exceeds the critical value, you reject the null hypothesis. It's the same as saying that when the p-value is less than the alpha, okay, that one too, you reject the null hypothesis. So the null hypothesis is something you are actually working against. Your goal is to reject that null hypothesis, but your p-value must be smaller and your critical value must be bigger for you to have the enough confidence to reject the null. After you have decided that way, you now conclude practically, statistically, and practically. Okay. So those are the steps in hypothesis testing. Now we are going to apply manually one of them. In the application of this, we are going to look at a very important table, this table. And I'm going to just treat this today. What I'm going to treat today is known as ANOVA, analysis of variance. So please write it down so that you know what ANOVA is about, analysis of variance. But before we treat this, I want you to please memorize, if possible, the table in front of you. There are so many questions you're going to be answering regarding this table in front of you. Anytime you're doing most of the hypothesis tests, you will use one of these. You use one. You will use one that is either parametric or non-parametric. You will use a parametric when the data is normally distributed. You will use a non-parametric when the data is skewed. What do we mean by, yes, Gordon?
Yes, okay.
Yeah.
If the default value, which is the alpha, which you say is a mistake or error you are allowed to make in the research.
No. Alpha is the mistake you actually make.
So alpha is a mistake you actually
alpha is a mistake you are allowed to make. Sorry, you're right.
Yes. So if you make the mistake in the research,
You are not supposed to make that mistake. You are allowed to make that mistake.
Yes, but relative to the p-value, which would be the actual error made in the research, won't it be the error that you are allowed to make in the research be the actual research that you actually made in the research?
No, that is why I say that they will, before you start a research, there is an error that is waiting for you, an allocated error that you are allowed to make. There is an allocated error that you are allowed to make in your research. It's not a research that is already like somebody supervisor or somebody will give to you. It's an imaginary error that you are allowed to make. And the only way you will know that you are making that error is that the software, when you run a hypothesis testing and you go into the software will tell you that error. The software will tell you. That was when you got to know that this is an error. But we know. You see, for example, you are allowed to put a certain money in the bank, or you are allowed not to take some money, a certain limit of a money from the bank. It doesn't mean you've actually taken some money from the bank. It doesn't mean that you've actually put some money into the bank. So it's an expected value.
Okay, no, so with regard to the p-value, which would be the actual error committed in the research, is there a measure, or is there a benchmark
The
that we can
benchmark
put?
here is the alpha. The alpha is a benchmark error that your p-value must not exceed.
So would we or should we are we able to quantify it like the way we actually quantify the alpha, which would be the default value as 5%?
You didn't quantify the alpha. Like I told you, the alpha has already been quantified before we were born. The alpha had always been existing, because whether you collect the data or you don't collect data, there is a certain modicum of error any researcher is allowed to make. But the moment you go and collect data, you start doing your research, you start writing analysis, you start calculating, you will be making some couple of errors. That is the actual error. And there's a percentage value. The actual error is a percentage value. We don't know that actual error. I can do my research, it will differ, mine will differ from yours. But then we will both be facing the benchmark error, which is 5%. We will both be having that expected error, the alpha, because that is the value we are all trying to go below. So if it is 5% and you went below it and you got 3%, and I went below it and I got 1%, we are all fine, but I'm finer because I got a smaller error than you. Yeah, Joa. Joa, your hand.
Yes, please. I want to know why you have to reject the null if the p-value is less than the alpha, and then.
Okay, so first of all, you know that both of them are errors, right?
Yes.
But one is expected error.
Yes.
And the other is actual error. Now,
yes.
the p-value is the actual error. Now, whenever you are doing a research, would you want to make errors or you don't want to make errors?
You don't want to make errors.
Okay. But then you have been told that even though you don't want to make errors, there is a tendency you will make. So they are giving you a limit of an error you should not go above.
Yes.
And that is the 5% error.
Yes.
Okay. You do your research, you know that you don't want to go above that 5%, you know.
Yes.
And you start the research, but along the line, you realize that you will make some error. That error becomes the p-value. Would you want that error to be above that 5% or you would want it to be below?
I want it to be below.
Now, once it is below, then you are within the limit, innit?
Yes.
And because you are within the limit, you can now go ahead and reject the null hypothesis. Now, why? Because the null hypothesis is a statement that you want to fight against.
Okay.
It is a statement that was made by an authority. An authority said that NDC will win the next election. You being Kweku Bako, you want to disprove that statement. And so you want to gather information from the Hansard. You want to do proper investigative journalism. You want to prove beyond reasonable doubt that that statement is false. You want to reject that statement. That is a null.
Okay. Okay. So the aim is to prove the null wrong.
That's it.
Okay.
We go to which test to use. When the data is normally distributed, it's a parametric test. Yeah, got it.
Yes, Doc. Is that what we usually call the the margin of error in research, the alpha?
Well, it depends on which aspect of the margin of error we are talking. No, it is not. I know what a margin of error is. It is not that one, but it's connected to that one.
Okay.
Yeah. When you are doing a research, the test you will use depends on the sample. When the sample is normal, you will use a parametric test. When it is skewed, you use a non-parametric test. Normal means the majority of the data are in the center. For example, most of you here, majority of your ages are around 35. Some are above, way above. Okay. When I say 35, let me be specific. Majority of you are between 30 years and 40 years. The rest are above. They will be a bit outliers. So they will be a bit, but majority of you are like that. For example, by the time we finish writing the exam for this course, majority of you will get around the same value. So most of the scores will be normally distributed. We normally draw it like this. This is how a normal distribution curve looks like. It is said to be a bell-shaped curve. That is when majority of the information is in the center. In such a case, the test you use is the one on the left. But if majority of the data is rather moved, for example, we do a test and many of you got above 80, and few of you got below, that is not good. That means that the score has been skewed to a higher value, or suppose many of you are failing, that also means that the score has been skewed to a lower value. So that's also not good. It's not good for this particular course. It has to be normally distributed. And so you have to choose a test. And here, every parametric test will have its non-parametric analog. For example, a parametric t-test, okay, which is called independent t-test, will have its non-parametric analog, which is known as Mann-Whitney U-test. So try and know the parametric version of every non-parametric test, and try and know every non-parametric version of a parametric test. Today, we are looking at a parametric test known as ANOVA. Sometimes it's called F-test. F-test. That's what we are going to do today. When is it used? You use this ANOVA when the sample is 3 or more. Note that down. When the sample is more than 2. More than 2. More than 2. What do you mean by a sample being more than 2? Okay, I gave you the example of the age. Let me go back there. Suppose I take the ages of students in this EMBA class, and I record all of you, your ages. How many samples is this? It's one sample, because I'm just dealing with ages of students in the EMBA class. Now, suppose I take weekend MBA students, their ages, and I also record the ages of all the weekend MBA students. And I decide to compare that of the ages of WMBA with the ages of EMBA. The moment I decide to compare these two ages, how many samples am I dealing with here?
2.
2. Now, suppose I bring the regular MBA student. I now have the ages of the regular MBA. Now I want to see across these MBA student groups, which of these groups are having older people, which of them are having agbalolocious people. I now have how many samples?
3.
When the sample is 1, the test you are using is T. When the sample is 2, the test you are using is T. When the sample is 3 or more, the test you are using is F-test or ANOVA. That's it. That is why today we are going to look at ANOVA test. By the time I finish, you would have understood what ANOVA is all about. Not just what it is all about, you're going to learn how to calculate it, interpret it, understand it, and apply it. Apply it in real life. So let's start. First of all, who can tell me the full meaning of ANOVA? You take a guess. What is the full meaning of ANOVA?
Analysis of variance.
Analysis of variance. ANOVA means analysis of variance. The focus, which word of these words do you think is the most powerful? Analysis of variance. Which one word is the most powerful in all of the words?
Variance.
Variance, that is it. Who can give me a synonym for variance? Give me another word similar in meaning to variance.
Deviation.
Deviation, okay. Deviation, okay. What else?
Difference.
Dispersion.
Sorry?
Dispersion.
Dispersion. And what else? Give me simple languages. Come on.
Difference.
Difference. That's so
Outcome.
simple and easy to understand and remember. Difference. What else?
Contrast.
Contrast. Okay, let's cover now. What is that? What is contrast?
Difference. Difference means difference.
Difference. So let's take a difference. ANOVA deals with differences. Let me give you a scenario and then we'll try to analyze ANOVA from this perspective. Okay. For example, there are so many things in ANOVA that you should check. But I'm going to use an example because the more I use an example, the more you will understand it better. So we're going to use this story here to understand ANOVA. Below are the salaries in thousands of Ghana cedis of some different MBA students. I wanted to see that this is actually, let's say it's actually 10,000 of Ghana students. So the RMBA students are making 10,000 cedis every month. 11,000 cedis every month. 12,000 cedis every month. 13,000 cedis every month. Is it 13? No. They are in tens of thousands. Oh, that means they are making 20,000. That's not good. So let's keep it at 10,000. Okay. So the RMBA students are making 1,000, 2,000, 3,000. The EMBAs are the rich people among us all. The one-to-ones. They are making 7,000, 8,000, 9,000. Let's even assume these are dollars. Then it becomes exciting. I hear you guys are very loaded. Is that true? Is it true that you are loaded? Or you are not loaded? You are all broke.
It's not true.
It's not true. You want to be humble, eh? You
Yes.
start speaking poverty into your life. It's not true. It's not true.
We are not poor either.
Well, if it is not true, you are either poor or you are not. They say that is true because King Solomon did not reject it. So why are you rejecting it? Are you wealthy or you are broke? If you don't answer, you are going to be poor and broke.
Hey,
So are you
well, we are rich. No, I'm rich.
Why is it that people are normally afraid of speaking wealth into their life? They make you look
We
like
are rich and wealthy.
they make it look like it's evil. It's not evil. If it is evil, God wouldn't have ensured that King Solomon had, or David, or even Abraham had. I had to calculate how much worth Abraham was. He was $520 million, according to 2020 calculation. That's interesting. You read Genesis chapter 13, verse 2, you will appreciate it. 1 and 2. So EMBA are having 7,000, 8,000, 9,000 in this context. Question is this: which of them is earning the highest salary? You can't just get up and say it. You have to subject everything to analysis of the variances. And so we are going to subject this whole thing, and these are the questions. This is a typical exam question. Okay. Is there a statistically significant difference between the mean salaries across these MBA groups? If so, if it is statistically different, then which group earns the least? That is the work we are going to do. So first of all, we are going to define the null and alternative hypothesis. Remember, this is a sample that are 3. In your own, the one you will do in the exam, it will not be 3. It might be 4, 5, or 6, but it will not be more than 6. So try and understand what we're about to do here, and you can appreciate yourself. Okay, now let's go back here. First question is to formulate the null and alternative hypothesis. The case of EMBA is very easy. It's very easy because the way you formulate the null and alternative hypothesis, the way you do it, ladies and gentlemen, the way you do it is constant. So it will not change significantly. Let's take this. How do you write a null and alternative hypothesis? This is how you do it. The null is always written like this. Always, oh. Remember, we are talking about the mean salaries, the average salaries. So take note that we are dealing with the mean. The symbol for the mean is mu. And because there are 3 different groups, you are going to have mu1 equal to mu2. Remember, the null always has equality. Equal to mu3, because there are 3 groups. You stop there. Then you go to the alternative. Write it. Write what I'm writing. The alternative will always say something like this: that mu I is not equal to mu j for at least, for at least 1 I j equal to 1 to 3 for every I not equal to j. You write it down first. This is somehow in your notes somewhere, but writing it down will make it stick in your mind. So what is the null saying? The null says, the null hypothesis is saying that there is no difference in the mean salaries. Write that down too, so that you don't forget. That's what it is saying here. Because if one is equal to the other, it means there is no difference. That's what it means. The alternative is saying that one of them is different from the others. If one, not even all of them are different, if one is different, we have an alternative. It scatters everything. It nullifies the null hypothesis. It nullifies the null hypothesis. So you just need one of them. So the means may even be, the groups might even be 100. And the null will say that they are all equal, they are all equal, they are all the same, they are all the same. Sorry, the null will say that there is no difference. Yes, so they are all the same, they are all the same. But alternative, all you need is one of them to be different and it will crash the entire null. You will see that because the groups are free, I have made it 1 to 3. And we've also confirmed that no particular I is the same as J. So these are different groups that we are dealing with. Who can tell me how to write a null and alternative hypothesis? If the groups were 6 groups, What will change on the screen here? Who can raise a hand and walk me through? If the groups were 3, what will change it? Is the class rep here? Class rep.
Please, I'm here.
Okay. Do you have an assistant?
Yes, sir.
Who's assistant?
I'm here.
Sam.
Okay. I'm making the two of you a co-host. I also want you to write the marks I'm going to give to the next set of people who are going to answer me, and then send it to me when we are done.
Okay.
So who can tell me how to do the null and the alternative hypothesis? So that's 3 marks. How will you change the null and you know?
I think the portion where we had the
No,
one
say
to
everything all over again.
okay, so the null hypothesis is such that mu I is not equal to mu
Now,
j.
did you say null hypothesis or alternative is what you're
Oh,
saying?
sorry, the alternate
We
hypothesis.
start with the null, Albaya.
So, the null hypothesis is such that mu1 is equal to mu2, equal to mu3, equal to mu4, equal to mu5, equal to mu6. And then the alternate hypothesis is such that mu I is not equal to mu j for at least one of ij equal to 1 to 6 for every I not equal to j.
Excellent. That is 3 marks. That's exactly how you should formulate the null and the alternative hypothesis. So I hope that in the exam you'll be able to do that. But now you have some 3 marks to put in the banking. Okay. So guys, learn how to formulate the null and alternative hypothesis. See, she didn't even know which group I'm talking about, but she was still perfectly able to formulate the null and alternative. So step 1 for this whole scenario case study, we've been able to handle it. We have been able to define the null and alternative hypothesis. Step 2 is to find the critical value. But I would like us to look at, the next question is to find a critical value, but I want us to look at the next one before we come back to that one, because it's easier that way. We are going to rather find the test statistic. Okay. Please note that the test statistic for ANOVA for 3 or more groups is known as the F test. F test, write it down, F test. So we are going to find that. But to do that, we need to create a table. So please draw this table as I also do it. Okay. The first aspect of the table is known as the source of variation. The source of variation. The source of variation. The next one is the sum of squares. The sum of squares. You will always draw this table anytime you are doing this in an exam condition. But of course, under real life of your research, you will not do this. You use the software to do all for you. The next thing is the degrees of freedom. The degrees of freedom, followed by the mean squared. And finally, you have the F test. Now, under each one of them, we have something we are going to fail. Under the source of variation, we are going to handle something known as the between group differences. The between group differences. And we are also going to examine the within group differences. So all the information to the right is going to be about the between group differences and then the within group differences. Our goal is to fill these 6 boxes. Box 1 here, this 2, 3, we're going to fill in these values. Then we know that once we are done for good. So what goes into this first one here, as the heading shows, is a sum of squares. Now, guys, just look at this. ANOVA means analysis of variance. The variances are of two kinds, or the differences are of two kinds. First, we have differences between the groups. For example, when you look at RMBA, WMBA, and EMBA, are there differences between them in terms of salaries? Are there differences?
Yes.
Yes.
Now, when you look at the same, just take RMBA alone. Within this RMBA alone, are there differences?
Yes.
Yes.
That is why analysis of variance looks at between group differences and within that same group difference. So what goes into the between group differences? This is it. It is the first part here is known as the SSG. The SSG. And that is the group sum of squares. It's read backward. Group sum of squares. It's all in your slide. What is that? Well, it is the differences between the groups. Between the groups. And it is given by a certain formula. Please write it down as I do. Ni, then summation x I bar minus x bar all square. Please write it. Okay. It's also in your slides, by the way. You can check it later. I'm going to explain each one of them to you. So xi bar, the I here is the group. Is a group. Is a group. Now, what is the Ni? The Ni is the sample size in this group, each group. So when you look at the RMBA, what is the value of N1? Because RMBA is group 1. What will be the value of N1?
3.
3. WMBA, what will be the value of N2?
It's also 3.
3.
EMBA, what will be the value of N3?
That's also 3.
3.
What do you mean can be? Somebody there. The person is there. He or she won't say anything to close. But those are the things I normally play back to give marks to. All right. So you have a situation here. Now you are going to look at X1 bar. The X1 bar simply means the mean in that group. And the X bar means the mama mean, the overall mean, the grand mean. It's not the mean of means, it's a grand mean. It is a mean of adding everything here and dividing it by every data point here. And when you check the data point, it's 9. So this is what you are going to do. We are going to calculate X1 bar. Okay, everybody's going to do it. You're going to find X1 bar. That is the mean in the first group. We're going to find X2 bar. And then you're going to find X3 bar. And then after that, you're going to find X bar. So take the first one and find the mean in the first group. Take the second one, find the mean in the second group. Take the third one, find the mean in that group. And then find the overall mean. And the overall mean should be adding everything here. 1 to 2 to 3, all the way to 9. And then whatever value you get, you divide by 9. And then find that as the grand mean. When you are done, send me your answer privately. And then start the maths. You have just 4 minutes to give me this answer. 4 minutes. Send me your answer privately. Let's go. I'm going to stop my screen sharing and show me. So this is exactly what you have to do. Okay. So Have it in mind, graphically, your box plot has been drawn, okay, indicating that Christians appear to be consuming a lot of wine. But we want to know whether that is statistically significant. The box plot is just a picture. Okay. The Muslims appear to be consuming less. You can see it from the median, which is a thick black line inside the box plot, followed by the Buddhists, followed by the Christians, who are seemingly consuming a lot of gin. The box plot has shown that. Let me remove this plot. Then we want to now do that statistically, and you have to use the ANOVA. The AOV is ANOVA. So you write something. This R here can be anything, can be results, can be your name, anything. So you write that to estimate the ANOVA using the data on Q. The Q is a quantity demanded of gin bitters. How does religious group, a different religion, how does quantity demanded change across religion? That's what you're doing. How does quantity demanded change across religion? So, and the name of the data is this, and then you summarize the results. So that's what we are going to run right now. Let's do that. Summarize the results, and you get this beautiful results down here. Okay, you get these beautiful results down here. What does this mean? Okay. This is beautiful. Now, guys, remember that when we were calculating the ANOVA for the different MBA groups, we did not use the p-value and the alpha to compare. If you can remember, we rather calculated a test statistic and compared it with a critical value. Do you guys remember?
Yes.
Yes.
Now, when you are manually calculating, in an exam, I will not bore you to find the p-value and the alpha. However, when you are using the software, I would want you to rather use the p-value and the alpha to conclude. So come down here, you will see that the ANOVA table that we did, okay, this is not exactly the same values because this is a different number. But you remember we had some column called DF. Do you remember? In our own. That is similar to what you have here. We also had another column called sum of squares. I don't know if you can remember, sum of squares. We called it SS. That is similar to what you have here. And you remember we had another column called MS, mean squared. That is also similar to what you have here. And then we also had a column called F test. That is also similar to what you have here. Of course, that data is different from this data. Okay. So there's the same thing that we have had. So you can see that this one is about religion, as we know it. So what do you look for to conclude? Always, you're going to look for the last column here, which is called the PR. The PR is a probability value. The PR is a probability. It's the same as a p-value. P means probability. P means probability. And you always check whether that value is less than 5%. Now, looking at the value I've highlighted right now, is it less than 5% or is not less than 5%? It's a very tricky value that has been written there. If you know, you know. If you don't know, you don't know. But I want to see those who know. That value I've highlighted, that 1.45 E minus 10, what does it mean? If you have ever used Excel before, you will know this. Deeply. You know it. Okay. Okay. So then take note. If you have any number that has E like this E is the exponent value. Okay. So E minus 10 means that there are 10 zeros before the first number. So I'll first give you some simple example. Suppose you have something like 1.2 E minus 3. Or you have 1.74 E minus 5. Or you have 2.3 E plus 2. What do these numbers mean? What it means is that the first one, it means that there are 3 zeros before the 1, 2. So if you are writing it, it will be 0.00. Okay, you bring the point after the first zero, but when you count the zeros, there are 3 zeros before the 1, 2. So this means that this thing you see here means you have 3 zeros before the 1, 2. Therefore, it is read as 0.0012. What about the second one? The second one means that there are 5 zeros before the 174. So it becomes 0, 0, 0, 0, 0. That is 5 zeros. Then after the first zero, you bring a point. And then you add your 1, 7. That is what it means. So it basically, this number here is almost 0. Then the third one means that there are 2 zeros after the 3. Okay, not before, but after. So you write the thing as 2 point, sorry, not 2, you don't bring the point. You write the thing as 2, 3, and then you add the 2 zeros, 0, 0. That means that there are 2 zeros after the 3. So this is how these things are interpreted. So when you see the one here at the bottom here, what does this mean now? Who can tell me? Okay. It means, yes, P.
Well, that means that 9 zeros before the 145. So 0.0000 or 9 zeros, 145.
Good. So that is how it is. That's how you interpret. So on the basis of this, we can conclude that our p-value is approximately what value? In this example.
1% or 0. Okay.
Yes. Is 0. Okay. Which means that now that is less than 5%, as we know. So it means that our p-value here is almost 0, and it is less than the alpha value, which is 0.05. Okay. So what does this mean? It means that we made no error at all. So what does this mean? It means we can reject the null hypothesis. But what is the null hypothesis always saying? In this very example, we are talking about religion. This null hypothesis was saying that there is no difference in the quantity demanded of gin consumed across the 3 religions. There's no difference. That the quantity demanded of gin consumed by Christians, that is the mean quantity demanded of gin consumed by Christians, is the same as the mean quantity demanded of gin consumed by Muslims, and that is the same mean quantity demanded of gin. So there's no difference. That's what it's saying. But this p-value we have means that there is a difference. So we reject the null and conclude that religion matters when it comes to the consumption of gin. Religion really matters. And on the basis of this, we should be able to identify which religious group consumes the most. Which religious groups consumes the most? Which religious group do you think consumes the most? Well, we know that the Christians consume the most, but you need to find the actual numbers to be able to know which religious group consumes the most. So how will you find that? In fact, let me just show you. But if you have a question, please ask now. If any of you has a question, just let me know. We are going to use something we call, describe by. We're going to use something we call describe by to be able to give us the exact means or medians, okay, of the. But to do that, we need to install a package. I just want to do that here for you. So let's go back here. So you have to install a package called library psych. library psych. Now, how do you do that? For those of you who have never done that before, go to the right here, the bottom right. This here is a tab called packages. You see a tab known as packages?
Yes.
Good. Click on packages and click install. A pop-up will come. Then you type psych. As you type psych, the psych will come. PS psych. As you type psych, the site will pop. And then you install that. I have already installed, so I will install the site. Click. When it comes, click install. If you have a great internet, install quickly. And then after that, you come and type this command, which is library site, and run it.
Please, where are you getting the packages from? I can't see that.
Click on install and type here, a pop-up will come. A pop-up will come. In that pop-up, you type psych. Did your pop-up come? Okay. Okay. So once you've done with that, you just run the command known as a library psych. Type library psych and run that command. But wait for the thing to finish installing. When you see a red dot on the bottom right somewhere, on the top right here, it means that it's installing, so don't interrupt it. When you see a red dot, it means it's installing, so don't interrupt it. Once it finishes, you see it at the bottom that it has finished. So you run library psych here. And then after that, you will type this describe command. And this describe command will give you the descriptive statistics for each of the religions. Okay, that is what is just did. You'll be able to do, let me do it again. Then. So it gives you the descriptive statistics for each of the religions. So watch this, you see that for Buddhists, they will tell you the number of Buddhists. There are 12 of them, Buddhist shops. And I will tell you the mean for the quantity demanded for Buddhists. Look at it. The mean is 180. But look at the median. The median for Buddhists is 190. Okay. How about Christians? Quantity demanded. The median for Christian is 210. How about Muslims? You see that it has divided it all for you. The median for Muslim is 150. So you can see that Muslim is 150, Christian is 210, and Buddhist is 190. So the quantity for Christian is 210. That is the highest. So if you are now asked which group consumes the least of gin, you know that is the Muslims, and you justify that with the number here. This is all part of your assignment you get. You justify that with your number here, which is because they consume 150 bottles of gin, just that. But the Christians consume 210. And what gave you that was this described by religion. And you can do this for any of the categorical variables. For example, one categorical variable was location. Another was occupation. You can do it for each one of them. So now, going back to our statistics, you remember we saw the ANOVA, the p-value to prove that there was a significant difference here. Now we know that there's a statistically significant difference in the quantity demanded across religions, across those religious groups. And so we can now say with a statistical method, with enough gravitas, reject the null hypothesis and conclude that indeed Christians are the heavy alcoholic consumers in this data set. So you didn't just say it, you justified that mathematically. That's it. Any question? Any question? Ladies and gentlemen, that brings us to the end of the entire caboodle.